All right, now I finished the last presentation, which was the first presentation in this series on set theory, with the claim that a set is defined by its members. And that is to say simply this, that two sets are exactly the same set if and only if they have exactly the same members. Now, you'll notice that when I say that, I don't talk about how we write the set, how many times we repeat the members in the set, or whatever the case may be. It's simply the members, not what order in which they appear or anything else. Now, let's just use that to answer the question which is set out here. And we're given 10 sets, A to J, and we're asked which of them are identical. Now, what's that mean? It means which of the sets, A to J, have exactly the same members. Well, set A has as its members just three things: London, Paris, and the White House. And the White House is in Washington, D.C. in the United States, and it's where the President of the United States resides. B has what's inside these curly brackets. These curly brackets here, the outside. You see we've got two pairs of curly brackets. B is the set which contains whatever is inside these curly brackets. Now, what is inside these curly brackets? Well, another set of curly brackets, and inside those curly brackets are London, Paris, and the White House. So what's in B? Well, remember, if we write curly brackets, and then, let's just write it up here. If we write these curly brackets, and then we write something down here, we are writing a set. A, you'll notice, has three members. It has the City of London, the City of Paris, and the White House. What does B have? It has one member, and that one member is the set A, the set containing London, Paris, and the White House. So members of B are not London, Paris, and the White House. Because a set is itself a thing, then B is just the set which contains the set A. So it is not the case that A equals B, because they don't have the same members. A has three of them, B has one. So we'll write it up here. A is not equal to, that's what this equals sign with a line through it means, is not equal to B. What about C? Well, that has three members, the White House, London, and Paris. Remember, it doesn't matter in what order we write the members when we write out a set like this by enumerating its members. And so those members are London, yes, Paris, yes, the White House, yes, and nothing else. So A is equal to C. What about D? Well, D contains a set once again. These outer brackets contain the members of D, and because a set is itself a thing, D is a set which contains a set. And what is that set that D contains? Well, it's a set containing just London, Paris, the White House, London, and Paris. It doesn't matter how often we write these members down. So the three members here, even though London and Paris are repeated, in fact there are only three different members here, and they are London, Paris, and the White House, which is the same, makes it the same set as B, because B is the set containing one member, which is the set, which is itself a set, and moreover that set containing London, Paris, and the White House, which is to say set A. So B and D are the same set. They contain the same things. So we can say, let's just note up here, B does equal D. Now what about set E? Well, set E contains two things, doesn't it? The object A, whatever A happens to be, we don't know, and moreover the second member of E is a set, the set containing A. Note that that isn't the same as F. E is not the same as F. Why? Because F is just the set containing A. We've written it twice, but only one thing. F is the set containing A. So E, let's go back here. What's E in that case? We can write it differently. E is the set containing A and the set F, because F is the set containing A. So E is not equal to F. What about the set G? G is the set of all X such that X is either the capital of France, which is Paris. Let's just write it there, despite the fact that my writing is so bad, or the capital of Britain, which is London, or the official residence of the President of the United States, and that is the White House. So what have we got? Just expressed another way, what have we got in this set G? Either the capital of France, which is Paris, it's either Paris, or the capital of London, or the capital of Britain, London, or the White House. So if anything is in it which is either Paris, so Paris is in it, or London, so London is in it, or the White House. London, Paris, and the White House. It's the same set in that case as A. So A is equal to G. Now what about H? H is the set of all things X, such that X is the capital of France, which is Paris, and the capital of Britain, and the official residence of the United States. Well, let's take a look at this rather closely, because this might appear at first sight rather confusing, but it really isn't. Let's look at it. H is the set of all X, all things, everything which happens to be the capital of France and the capital of Britain. Well, the capital of France is Paris, and the capital of Britain is London. And what thing is London and Paris? And, moreover, the White House. So H contains anything which is Paris and London and the White House. Well, I can't think of anything which is all three of those things wrapped up, so it's important to note here that H is not equal to A. It is not London, Paris, and the White House separately. It is the thing or things which are all of those things. So A is not equal to H. What about set I? I is the set of all things X, such as X equals A. It's the set of all things which are A. In other words, let's just put this arrow here. I, the set I, is equal to A. Now, what else do we have here? Well, F is the set that has A as its member, as its one member. So I and F are the same thing, and let's just note it down here. F is equal to I. And then let's look at this set down here, J. Now, J is the set which, well, it's got this curious mark here. That's in fact, let me just write it again. It's a circle with a line through it. And that means that it is the empty set. J is the empty set. This simply means that it's nothing. There's nothing in J. Now, when I say the empty set, why do I not say one of the empty sets? Well, remember, two sets are the same just if they have exactly the same members. That is to say, there is nothing in one which is not in the other. And if you have two empty sets, there is indeed nothing in one which is not in the other. So there is only one empty set. Now the question for us is this. If J is the empty set, is it identical to any of the sets A to I above it here in this question? Have we, amongst A to I, got something which is the same as J, that is, the empty set? Well, all of these sets contain something. A contains three things, B contains one thing, which is a set, C contains three things, D contains one thing, E contains two things, F contains one thing, G contains three things, I contains one thing. What about H? Well, I said before that H is the set of all things which are both Paris and London and the White House. There is no one thing which is Paris and London and the White House. There is a set containing London, Paris, and the White House, but there is nothing that is all three of those things, rather than the set of all three of those things. So let's just write it here. H is empty. There is nothing. Nothing fits the bill. So H is the empty set. And therefore, let's just put it here, H is equal to J. So in summary, let's just look at where we are. We have A equal to C, B equal to D, and A equal to G. Well, let's just add that in up here. If A is equal to G and A is equal to C, the same thing, then C is equal to G. So let's just add that in up here. So we have A, C, and G are the same set, B and D are the same set, F and I are the same set, and H and J are the same set.